Greetings, wonderful students. How are you all doing? Today, we're going to do the last math of the whole semester, okay? That is awesome. We're going to learn how to calculate chi-square. So let's get right to it. I'm going to click this Soc 201 chi-squared lesson, and that will bring up a PowerPoint. What we're going to do today is calculate a chi-square. Then we're going to look in an appendix for a critical chi-square. We're going to calculate degrees of freedom, and we're going to make a decision whether we accept or reject the null hypothesis. Sounds kind of familiar, huh? Yeah, we just did that exact type of thing when we did the last lesson, differences between means. Okay, so when you see a problem for chi-square, you're going to see the observed frequencies. Those are just numbers, okay? You're going to have to calculate the expected frequencies, which is really simple to do, in order to work the problem. The symbol for chi-square is just this x squared symbol. And we could see the difference in chi-square as we're working the problem between the observed frequencies and expected frequencies. The null hypothesis is expressed this way. H sub 0 is a null hypothesis that the observed frequencies will be equal to the expected frequencies, and are we going to accept that or reject that hypothesis? Same kind of thing that we did with differences between means. Is the population equal to the second population? Okay, so some similar stuff in this lesson. Like I said, the observed frequencies are given in the problem, and we have to calculate the expected frequencies. When you work the problem, down here in the lower right, it shows the chi-square formula. X squared is the symbol for chi-square, and the formula is the sum of all of these individual fractions that you're going to create with the observed and expected frequencies. You're going to set up an individual fraction or a formula with each pair of observed and expected frequencies. Then you'll do the math and add up all the numbers, and that will give you the calculated chi-square. And degrees of freedom. There's two types of problem here. One with one row of data, and in that case, to get the degrees of freedom, you're just going to subtract 1 from the number of categories. That's what C stands for. You'll see that in a second. If you have more than one row of data, then you calculate degrees of freedom by the number of rows minus 1 multiplied by the number of columns minus 1. Okay? Okay, here's an example of a problem with just one row of categories. And here you see this little tiny table with one row of categories. 4 students at CSUSM. How many times they stress out every month? It's a good thing they didn't put me in here, because there'd be another cell here with like 500. That's how many times I stress out every month. Okay, but we have the first student stresses out 20 times a month, the second student 18, the third student 7, and the Stepford student who only stresses out 3 times a month. All 4 of these numbers are observed frequencies. In order to get the expected frequencies, we need to add up all four of these numbers. That will give us the total n by the number of categories, or students in this case. And this is what happens. We add up these four numbers. 20 plus 18 plus 7 plus 3 equals 48. And we just divide that by the number of students, which is 4. And that'll give us 12. So for each cell in this problem, when we set up the chi-square fraction, the expected frequency is 12. Okay, so observed frequency for the first student is 20. The expected frequency for the first student is 12. The null hypothesis: in the entire student body at CSUSM, no difference exists in how often students stress out every month. In order to reject this hypothesis, the chi-square value you calculate must be larger than the critical chi-square value that you find in the appendix, right? Sounds similar, doesn't it, to the t ratio that we calculated in the last lesson. Exact same rule. Whatever you calculate has to be larger than the critical value you find in the appendix in order for you to reject the hypothesis. Wow, look at all those numbers. Okay, here again is the formula for chi-square. You see that it's the sum of all the individual fractions that you set up like this. Now we know that the observed frequencies are here in this row. And we also know that the expected frequency for each fraction is 12. So the first fraction that I'm going to set up is with the observed frequency of 20. And just like it's pictured here, the observed frequency minus the expected frequency, and that result is squared. And then you divide that number by the expected frequency. So for the first cell of 20, it's going to be 20 minus 12, and then we're going to square that result and divide that by 12. For the second cell, or the second student, who stresses out 18 times, we're going to have this fraction. The observed frequency is 18 minus the expected, which is 12. We're going to square that result and divide that by the expected frequency. And you do the same thing for the last two numbers, 7 and 3. Okay, so I have this row, and the next row, I'm just doing the math. Okay, 64. That is 20 minus 12 equals 8, and 8 squared is 64. 18 minus 12 is 6. 6 squared is 36. And the expected frequency of 12 just stays as the denominator in the fraction for each one of these calculations. And then I continue on down and dividing 64 by 12. Let's see if I'm right here. 64 divided by 12 is 5 point, but I'm just going to reduce it down to 5.3. Okay? 36 divided by 12 is 3. 25 divided by 12 is 2.1. 25 divided by 12 is 2.08. So I'm just going to round that up to 2.1. 81 divided by 12, 6.75 exactly, so that's what I have. And then when I finally get through the problem and I have my numbers, I'm just going to add them up and get 17.5. That is my calculated chi-square. I have that here, the calculated chi-square. In order to get degrees of freedom, I need to look at the number of categories, or the number of students. Minus 1, there are 4 students. Minus 1, so the degree of freedom is 3. And from the appendix, I'm going to find the degrees of freedom, which is 3, and move to the right until I find the column 0.05. And that critical chi-square is going to be 7.81. Now let's look at that a little bit. Here's the appendix that's in the class this week. Okay, degrees of freedom, again, is on the left-hand side. I'm just going to move down to 3 and go straight across until I get to 0.05, and that's where I find 7.81. Okay, so that's how I get these numbers. So degrees of freedom is 3, calculated chi-square is 17.5. The critical chi-square is 7.81. And I have to answer this question. Do I accept or reject the null hypothesis? Well, is the calculated chi-square greater than the critical? Yes. So I'm going to reject the null hypothesis. The 4 answers that you're going to give me for chi-square problems are going to be degrees of freedom, the calculated chi-square, the critical chi-square, and your answer, accept or reject. Okay? Awesome, isn't it? Don't you love doing all this stuff? I mean, I'm sure you can see how this is going to benefit you later in life. But actually it will, because believe it or not, going to college is not about getting grades. It is about teaching your mind how to think and work your way through difficult problems, because that's what you're going to be doing for the rest of your life. Okay, example 2 has more than one category. Okay, it's kind of like a crosstab table or cross tabulations, which you're going to see later in the semester when you're using SPSS, the software. More than one row of data. Here's an example. Gender and income. For the first time, I think I'm introducing you to the idea of independent and dependent variables. Gender is a variable, income is a variable. In this pairing, gender is the independent variable because it is the one that affects income, which is the dependent variable. You think about it. I'm sure you've all heard whether you are male or female is going to affect or may affect what your income is on a job. It's well known that males just make more money than females in certain jobs, which is completely unfair and stupid in my opinion. If I owned a company, I would want to pay a valuable employee what they were worth. But getting back to independent and dependent variables, your income is going to depend on whether you are male or female or identify as another gender. That's why gender in this pairing is the independent and income is the dependent variable. And we'll talk about that some more when we get into crosstabs. Okay, here is another example of figuring out a calculated chi-square. This time you have 2 rows of information. And here I have the descriptions. The numbers in white font, these 8 numbers, are the observed frequencies, exactly like the last problem that just had 1 row of data. But we need more information here. The yellow numbers in this table are row and column totals, right? Like 20 plus 32 equals 52. 31 plus 20 equals 51. The column those are the column totals. The row totals are these 2 yellow numbers over here. If you add up 20 plus 18 plus 31 plus 28, you should get 97, hopefully. If you add up these 4 numbers, you'll get 103. And then the large number at the bottom right is the total n. That means if you added up all 8 numbers, you would get 200. Okay, so the total of these four column totals is 200, and the total of these two row totals equals 200. And you need all of these numbers in order to work through this problem. It's going to sound complicated, and it's going to sound funky. And I know we're all stressed out, man. I am so stressed out. But I believe in you, and you may have to watch this video a couple times, but I think you can make your way through this. Okay, remember, the white font numbers are observed frequencies, and we have to calculate the expected frequencies. And this is how we're going to do it. You multiply for each cell the column total times the row total and divide by the total n to find the expected frequencies for first the top row of numbers. So what I've done here is replaced the observed frequencies in white font with the expected frequencies in the top row that I'm calculating. And for this first cell, I'm showing you the fraction down here. I'm multiplying the column total times the row total. Here's the column total of 52 times the row total of 97. And then I'm dividing that by the total n, 200. So if I do that, 52 times 97 divided by 200, I'm going to get 25.2. And that is my observed frequency for this top left cell. Okay, let's do another one here. For the second number in the top row, I need to do the same thing. I need to multiply the column total by the row total and then divide that number by 200. So let's do that. I'm going to multiply 43 times 97 and get that result and divide that by 200. And what I'm going to get is 20.855. And I have just rounded that up to 20.9. Okay? The next number, I'm going to do exactly the same thing. In order to get 24.7, I'm going to multiply 51 times 97, get that result, and divide that by 200. And it's going to give me 24.735. And I just round that down to 24.7. Okay? The concept is confusing. The math is not. You know, this is simple stuff that you go step by step, calculate each expected frequency. Now, when I'm done with the top row, then I have to do the bottom row. Okay? Now here in the top, I have the expected frequencies that I've calculated for the top row, and I'm going to start with the bottom row. We're going to do exactly the same thing. Multiply the column total times the row total and divide by n. The difference here is that we're using the bottom row, so the row total is now going to be 103. Okay, so in order to get this number, 26.8, I'm going to multiply 52, which is the column total, times 103, which is the row total here, get that result, and then divide by 200. And that gives me 26.78, which I'm going to round up to 26.8. The next number in the bottom row, I'm going to find 22.1 by multiplying 43 times 103, get that result, and divide that by 200. And that gives me 22.145. which I'm going to round down to 22.1. Okay? You see what I'm doing? I calculated expected frequencies for the top row, and then I'm going to calculate expected frequencies for the bottom row. And as you work through these problems, you're going to have all these numbers below each other. So you'll be able to see all the observed frequencies and all the expected frequencies as you work through the problem. Okay? So once I have that, now I have all the observed frequencies from the beginning of the problem, all of these numbers, and I have worked through calculating the expected frequencies for the top row and the bottom row. And then it's just a matter of doing the same thing we did in the first problem, but here you just have more fractions. There's two rows. So you have fractions for the top row and a group of fractions for the bottom row. Okay? Just set them up, work steady, stay calm, and do each fraction with the observed and expected frequency for that particular cell in the table. Remember, the first cell had an observed frequency of 20. The expected frequency that we calculated was 25.2. So 20 minus 25.2, I'm going to square that result and divide that by 25.2. The next cell, remember, the observed frequency for the second cell in the top row was 18. The expected frequency was 20.9. So I have those two numbers here. 18 minus 20.9, square that result, and divide that by 20.9. And you keep going, cell by cell, and use the observed and expected frequencies. So you have the top row with the top row numbers, and then the bottom row with the bottom row numbers. Okay, what about this one here? 20 minus 26.3. Well, remember, in the original table, 20 was the observed frequency in the third cell of the bottom row. And when I calculated the expected frequencies, 26.3 was the expected frequency in the third cell in the bottom row. So here you have those two numbers. 20 minus 26.3, square that result, and divide by 26.3. So after you have all these fractions set up, you just start doing the math. And here is the next, sequence of numbers. I went from here and I did the math for the numerator in the fraction for every fraction. So I come up with these 8 fractions, okay? 27.04 divided by 25.2, right? How did I get that? 20 minus 25.2, I'm working on this top left fraction. And it gives me a negative 5.2. So I'm going to square that, which gives me 10.4. Actually, let's just do this. We'll do 5.2 times 5.2. Because you know that a negative times a negative gives you a positive. So we have 27.04 divided by 25.2. Okay, 27.04 divided by 25.2, and it gives us 1.7 and 1.07 and a whole bunch of numbers, which you can see here. I round it down to 1.07. So just work each fraction individually. You know, this one, the last cell, the fourth cell in the bottom line, what you get when you subtract 27.8 from 26 and square that number, you get 3.24. Hey, there goes my answering machine. Hold on a minute. Okay, so the last cell is going to give us 3.24 divided by the expected frequency of 27.8. Okay, now if we do all the divisions in these fractions, then we're going to get all these numbers. And once you get to this point, just like the first problem, all you have to do is add up all the numbers, and what you're going to get is 6.21 for a calculated chi-square. Okay? Then you have your calculated chi-square. You have to figure out what the degrees of freedom are. I don't know what that is. Remember, for a problem with more than one row, it's the number of columns minus 1. There are 4 columns, times the number of rows minus 1. And there are 2 columns. So it's going to be 4 minus 1 is 3 times 2 times 1 is 1. And it's going to give us the same degrees of freedom. Okay? In the appendix, just like we did before, we went to 3 degrees of freedom and went over to the right and found the 0.05 column and found 7.81. Let me go back up here and show you that again. Same thing. Here's the appendix that's in the class this week. 3 degrees of freedom, all the way to the right over to the 0.05 column, and find 7.81. So we have 3 degrees of freedom, a calculated chi-square of 6.21, and a critical chi-square of 7.81. Do you accept or reject the null hypothesis? And in this case, we're going to accept it because the calculated chi-square is not larger than the critical chi-square. In the first problem, it was. In this problem, it is not. So we're going to accept the null hypothesis. So if this was a problem in your problem set or on the midterm, you're going to give me these 4 answers. 3 for degrees of freedom, 6.21 for the calculated chi-square, and 7.81 for the critical chi-square. And then just write accept or type accept. Those 4 answers are what I need. Okay? You're going to do the chi-square problem set. I'll give you another video about that. I know this is complex and, we're all stressed out, but I promise you, if you just try it a few times, work through these problems slowly and evenly, step by step, just like the great man said, again, you will be able to do this. And you can certainly email me with questions or come into the office hour. All right, I'll see you in the assignment video. Okay, have fun.